In this example, we have a particle projected up an inclined plane with its initial speed u. The line of projection makes an angle of alpha with the plane and an angle of beta with the horizontal. And we're asked to prove that if the particle lands traveling horizontally, then 2 tan A tan squared b is equal to tan b minus tan A. The key in these questions with landing angles is the velocities at impact, v of x and v of y. And the reason is, if we imagine a particle coming into land that strikes at this point, we have the velocity of x and the velocity of y making up this vector coming in this direction. And if this is the angle C, we can say that the tan of C is opposite over adjacent. I wrote x there, let's try to write y, it looks like an x. So the tan of C is the velocity in the y direction over the velocity in the x direction, and you all know that this is a negative slope coming down in this direction, so it's negative. So that's why we need the velocities. So let's start this question by setting up our equations. We have our normal equations here. Our initial velocity is equal to u cos A in the I direction plus u cos B in the j direction. Sorry, u sine B in the j direction. The accelerations in the I direction is going to be minus g sine beta, and in the j direction minus g cos beta. We need the velocity, so v of x is equal to u plus at, u cos alpha, plus a is going to be minus g sine beta times t. So we need the time taken to get the impact so we can get these velocities. So that's when s of y is equal to 0. So let's do that first. When is s of y equal to 0? So we're going to have u sine beta ut plus a half at squared, so minus the acceleration g cos beta by t squared, and the half is the 2 on the bottom. So when is this equal to 0? It'll tell us the time of flight. We factor out t, u sine beta minus g cos beta times t over 2 will be equal to 0. So we'll get 2u sine beta put a b in here instead of an a. Just change that, sine a, sine a, sine a. If you can't identify your mistakes, you're in trouble. Sine a over g cos beta, that's equal to t. So I can get my v of x now. I also get my v of y. V of y is equal to u plus at, so u sine alpha minus g cos beta times t. So let's get v of y first. So it's going to be u times the sine of a minus g by the cos of b times t, which is 2u sine a over g cos b. So we're going to get u sine a minus 2u sine a, which is just equal to minus u sine a, and then the velocity in the x direction is going to be u cos a minus g sine beta times t. So that's 2u sine a over g cos b. So the velocity in the x direction is going to be u cos a and we're going to have minus g sine b over, well, the g's cancel, apologies. We're going to have sine b over cos b, which is tan b, and we have 2u sine a. So as we said before in these questions, we have a cos a here and we have a sine a. If we divide, so again, phone on when you're working, sometimes you have to, when you have kids, divide both by cos a. We're going to get v of x being equal to u minus 2u tan A tan B. So the landing angle, and we know because of the alternate angles in this case, it's landing horizontally, and we have a B in here, B in here. We can say that tan B is equal to minus the velocity of y, so that's going to be minus this guy up here, so plus u sine A, divided by the velocity of x, which is u minus 2u tan A tan B. So cross multiplying, we're going to get u tan B minus 2u tan A tan B equal to u sine A. So we divide across by u. We could have done it earlier. So we're going to get tan B minus 2 tan A tan B is equal to sine A. I'm thinking I may just reverse tack and not divide by cos A here first. So let me write tan B is equal to the u sine A. It'll be minus u sine A over, that's Vy over Vx, which is u cos A. U cos A minus 2u tan A minus 2u sine A tan B. I didn't divide everything by cos B the previous time. I think it's a mistake. So multiplying across now, I get tan B by u cos A minus 2u sine A tan square B is equal to u sine A. Dividing across by u, or doing it earlier if you want. And dividing across by cos A now, so this is where I kind of had divided here by cos A, and I hadn't divided every term. So dividing by cos A now, you can see here what's going to happen. These will cancel, so I get tan B minus 2 tan A tan square B is equal to tan A. And they wanted, the format they wanted it in was the 2 tan A tan square B on its own. Let's bring that to the right. We'll have tan B minus tan A on the other side. And that's the final format that they were looking for it in here. So just be careful with not dividing too early. Take your time finishing off these questions. There was one more part I think to this question. If tan A, find tan A if beta is 45 degrees. So if beta is 45 degrees, the tan of 45 is equal to 1. So therefore the tan of beta is equal to 1. So I get 2 tan A times 1 is equal to 1 minus tan A. So that should be 8. So 2 tan A plus tan A, 3 tan A is equal to 1. So tan A is equal to 1 over 3.